All right, folks. Well, this time around, let's look at parameter passing in some detail. So we want to consider different parameter passing mechanisms. We'll look at optional parameters. We'll look at variadic functions, functions that can accept any number of parameters. So you could call it with 1, 2, 3, 5, 10, however many you like. And we'll look at keyword-based parameter passing instead of positional. So I'll talk about that when we get there in a little bit. So first off, the optional parameters. You're used to this from lots of other languages, I'm sure. The idea is we can have some parameters that the user may or may not pass. If they don't pass them, then we'll have some kind of a default value for them. So the way we do this in Lisp is to specify any required parameters first, and there don't have to be any required parameters, but if you've got required parameters, they come first. And then you use the keyword and optional. Everything after that point is an optional parameter. And for each of them, what you specify is a pair that gives the name and the default value. And again, default values can be anything. Here we've got two optional parameters, y and z. Y has a default value of 10. Z has a default value of the string foo. So they've got to pass at least two parameters for the w and x. If they do pass just two, then it uses the defaults for y and z. If they pass three, it uses the value they passed for y and the default for z, and if they passed 4, then it uses the values they passed for all 4 of them. And of course you can't pass more than the supported number of parameters. So pretty straightforward. If we wanted to do, in this case, let's look at getting an integer from the user. And so what we're going to do is say, we're going to prompt the user to enter a number in a specific range. So we want a kind of generic getInteger function that can take a value in any range. And so what we'll expect is for the user to provide the lower and upper bounds on the range that's going to be supported. And what we'll do is, by default, if they don't provide a lower bound, then we'll just use the most negative number that the system can support. So essentially it's saying, anything that you can enter is valid. Right? There's no lower, it's going to be greater than or equal to this. And for the upper bound, we'll pick the biggest integer it can represent, right? So the biggest integer the system can support. So most negative integer, most positive integer will be our default bounds. So if somebody just calls getInt, it's essentially going to accept any integer that they can enter, because anything they can enter that the system can recognize is going to fall somewhere within that range. If they give us just one value, then that's going to be treated as the lower bound, and it's going to be looking for them to enter something between that value and the biggest possible value. And if they enter two values, then it's going to expect something that's in that range. So as far as our error checking goes, when somebody calls getInt, we're going to want to make sure that the values they pass are integers, and if they pass two of them, then we probably want to make sure that the max is greater than or equal to the min, but other than that, it should be pretty straightforward. So let's take a bit of a look at that. So let's say we write our getInt, and we're going to specify these optional parameters. Min is by default the most negative, max is by default the biggest. I'm going to use a let star block just to make sure that our local variables get initialized in the sequence that I'm anticipating. And what I'm going to do is use local variables for the actual lower bound and the actual upper bound, just in case they gave us garbage values for min or max. And I'm going to use one more local variable for the user value that they eventually type in. So for that real minimum, I'm going to check if they gave me an actual integer for the minimum, I'm just going to use that. Otherwise, if they didn't provide anything, or if they didn't provide an integer, then I'm just going to use that default most negative value. And then for the maximum, if they provided an integer that was actually at least as big as the minimum, then I'll use it. Otherwise, whoops, that should be a most positive fixed num. Right? Otherwise, I'll use the most positive fixed num there is the biggest number that there is. So we should go through, check that, and beyond that point, then I can go through and maybe even customize the prompt a little bit. So instead of always saying enter an integer between this and that, where a lot of the time the two values are going to be these huge negative and huge positive integers, if we're using the defaults, then maybe I'll just say enter an integer, because anything they can enter is going to fall in that range. It's going to be recognized as in that range. If they just gave me one bound, so if they gave me the upper bound, then I'll just say, enter an integer less than that. And if they just gave me the lower bound, I'll say enter an integer greater than that. Now, at the moment, we don't have a way for them to enter the upper bound without the lower bound, but we'll look at keyword parameter passing later to see if that's possible. And otherwise, if they gave us both bounds, then we'll say enter an integer between blah and blah. Right, so we can customize the prompt a little bit based on our knowledge of what the ranges happen to be. Okay, then the usual sort of approach. We've prompted the user, we'll read what they type in and store that in the user val local variable. We should check and make sure it was actually a number. So if it wasn't a number, then we could print an error message and make a recursive call. Right now I'm just making the recursive call. If they gave us something that was smaller than the minimum, again, you could print an error message and do a recursive call. Yep. Whoa. Sorry, I just closed my window on me. If they gave us a number that was too big, again, we could give an error message and do a recursive call. And otherwise, they gave us something valid, we'll just return it. So for these recursive calls, instead of just having the function call there, I could do something like have a block where I printed out, here's the error message, and then do the recursive call. And the return value for the block, and hence for the cond, is going to be the actual value or what comes back from our recursive call eventually. So the other place we're going to see this kind of thing crop up a lot are with accumulators, where we were talking about tail recursive functions. Well, if we have something where I've got this kind of public call that has one parameter and then a hidden helper function with a bunch of accumulator parameters, what I can do instead is just to give the public version a bunch of optional parameters that are the accumulators that default to the original value I would have used for the accumulator. So the values I would have used in the very first call. So for instance, if I wanted to come up with something that was going to find the smallest value in a list L, then what I could say is, okay, you give me the list, and we're going to keep track of the smallest value I've seen so far. And if that isn't provided in the original call to smallest, then I'm just going to assume it's the biggest possible number, right? Since whatever they give us is going to be that or less. Whatever it works out to is going to be that or less. So usual idea, first we do our error checking. If it's not a list, or if the list is empty, then we'll just return whatever our computed or default value is for the smallest thing so far. If the thing in the front of the list isn't an integer, we'll ignore it and just do a recursive call, again passing on the rest of the list and the smallest thing so far. Otherwise, if the thing in front is smaller than the smallest thing we've seen so far, we'll do our recursive call with that, right? Say, okay, well, look at the rest of the list and compare it to this new smallest value. And otherwise, the thing in front is bigger than or equal to the smallest thing so far, so we'll just continue on searching based on the smallest thing we've seen so far. So check the rest of the list using the smallest value we've seen so far. And so again, these optional parameters are useful for setting up and providing initial values for our accumulators. All right, the other one I mentioned was variadic functions. So this idea of having a variable number of parameters for a function. So a function can take 1 parameter, 2 parameters, 3 parameters, 50 parameters, 500 parameters. I'm sure there's an upper bound, but hopefully it's more than anything we're likely to actually wind up using. So the idea would be the user could call, f of 1 or f of 10, 20, 30 or f of 600, 502, 6000, foo, the list 1, 2, 3. You could provide any number of parameters of any types you wanted. So the way it's done is with this keyword and rest. So again, we specify any required parameters up front, and then any optional parameters and their default values. And again, you don't have to have required parameters. You don't have to have optional parameters. But if you do have them, they go in this order: mandatory first, optional second, and then and rest is the keyword, and some parameter name. I'm going to use L here. And all of the additional parameters that they provide, anything beyond the mandatory and optional ones, winds up in this list L. And so inside the function, you can figure out, oh, they gave, this list has got 40 elements in it, so they must have passed me 42 values in total. I used the first one for x, the second one for y, and the other 42 are sitting in this list. So in the function, you can go ahead and do whatever you want with that, and you can support any number of parameters at all. Now, the one place where it does get kind of tricky is if you want to make recursive calls based on the values or some of the values that are in L. So let's say somebody passes me f of 1, 2, 3, 4, 5. So here my mandatory parameter x would have the 1, and the rest of them would be in L. Suppose inside there I wanted to do something like make a recursive call that involved that first value and everything except the front of that list. So I want to make a recursive call that looks something like, I don't know, f of 1, 3, 4, 5. So I've got a bunch of values from the list and that other value, and I want my recursive call to look like this. Well, I can't simply pass x and something like the tail of L, because then it's going to stick this 3, 4, 5 into a list, and it's going to make the call f1 and then a list 3, 4, 5 instead of the values 3, 4, and 5. So my recursive call isn't going to look the same as the initial call did. Right? When I get in here, it's going to turn around and say, oh, well, x is 1, and then L is a list of one element, and that one element is a list 3, 4, 5. So it gets a little trickier to do your recursive calls with this. Just to take a sneak peek at higher order functions, what we can do is call a function called apply that says, here's the name of a function, and here's the list of things to use as its arguments, as its parameters. And so what we'll do is stick the front value, stick the 1 onto the 3, 4, 5, form a list like that, and say apply f to this list 1, 3, 4, 5. And that will give the format that we want for our function call. So if I say something like apply f and then the list 1, 2, 3, it's going to act like f of 1, 2, 3. That should either be an f or that should be a plus, one of the two. So apply is going to be very handy when we're trying to do things like this in the near future. All right, if we wanted to go through and do smallest again with something like this, where I say I want the smallest value in however many parameters they give me, I could go through and check what I've got for the values in L, and maybe if there's no values in there that are integers or numbers, then I can use most positive fixed num or most negative fixed num or whatever it might be. But I can go through and apply this same sort of logic. So what am I doing here? I'm setting up a couple of local variables, and actually we're going to do most of our work in our couple of local variables here. So I'm going to have something that figures out the front value and something that figures out the smallest value in all the rest of them. So if the length of L is bigger than 1, then I'm going to call smallest on the tail of L. Right? So it's going to get me the smallest value in the rest of them. And if the length of L is less than or equal to 1, then I'm just going to use the most positive fixed num, the biggest number possible, as the smallest in the rest. And then for the front, I'll do something similar. If the list isn't empty and the thing in front is an integer, I'll use it. Otherwise, I'll use my default value, the most positive fixed num. So now I've got two numbers in the smallest in the rest, and whatever the front is, and we can figure out what the smaller of the two is in the body of the function. So we just compare whatever's in front and whatever's in smallest in rest, and return whichever one of those is less. Again, this time around, we did all of the real work here. Right? Either with our recursive call to smallest or with our comparison here. So this works out reasonably well. Lots of stuff you can play with. Of course, if we have, let me see if I can find my other version of smallest here. So if we've got something like, let's see. So here we've got, the top part is just that get integer function that we were discussing earlier. Here we've got our version of smallest that takes our list L and an optional parameter for the smallest value so far. So this was the tail recursive version for going through a list of values and finding the smallest. If somebody gives me my list as a bunch of parameters, so if I wanted to use a variadic function to figure out the smallest value in the list, and I've already got the smallest value in the collection of parameters, so you can call othersmallest on 1, 2, 3, othersmallest on 10, 20, 30, 6,500, 2, 6, 9, well, whatever. Then, knowing that I have this other one that works for lists, I could simply cheat and say, well, let's just call the one that works on lists. Right, that's perfectly valid as well. However, let's see, where else did we want to go? Keyword parameters. So, nearly everything that we've played with in terms of parameter passing in most of our languages are positional based. If you pass 5 parameters, the first one that you pass goes to the first parameter in the functions list, the second one you pass goes to the second parameter in the functions list, etc., etc., etc. It doesn't necessarily have to be that way. So one of the ideas that Lisp provides is called keyword passing. So this is done by specifying and key as a keyword first. And then what we'll do, when we call a function, we can give the parameters that we want to pass in any order we like, but we specify the names of which values go to which parameters. So it does mean that when you're making the function call, you have to know the names that the function used for its parameters, but I can do things like this. I can specify that I've got some function and I'm going to use keyword parameter passing instead of positional. My parameters are called E and L. So when somebody wants to call display, they can say, okay, I want to pass 3 to E and I want to pass this list to L. But it doesn't matter what order they give those two things in. They can say, oh, here's the value I want to use for L, and then here's the value I want to use for E. So instead of passing them in sequence, you're just passing them specifying which value, the name of the parameter whose value is coming next. So you will run across this. Actually, we're going to see this kind of notation again when we look at structures pretty soon. But this is just an alternative approach. Right? If you don't want to have to worry about what order things are passed in, then trade-off means that you've got to know what the names of the things are. All right, that's a good place to leave the parameter passing for now. Pretty much from this point out, I'm going to make fairly heavy use of optional parameters, and especially when we get back into macros, we're going to start using and rest more as well. The positional or keyword-based parameter passing we probably won't use so much, but we will rely on the others quite a bit.